Okay, so we'll go back to our video. Here's an interesting question from the 1966 International Mathematical Olympiad. This is question number 4. We want to show that for every natural number n and that for every real number x does not equals k times pi divided by 2 to the power t, where t equals 0 all the way up to n and that k is any integer, that the following equality holds. We have that 1 divided by sine of 2x plus 1 divided by sine of 4x all the way up to plus 1 divided by sine of 2 to the nx is equal to cotangent x minus cotangent 2 to the power n of x. So an equality like this is very interesting. We're actually going to be utilizing some tangent half angle properties to utilize the properties for everything, especially with the sine and cosine using that definition. And it's a simply matter of just plugging stuff in with, again, there's a lot of algebra involved. Well, I say a lot, but again, once you have everything, all the pieces together and you plug it back in, then all it's left is just to make sure that it actually verifies the following from the left-hand side to the right-hand side, which of course it does, which is why we're trying to prove that. So with that out of the way, and then anything else that really needs to go on, again, a lot of algebra, not too much. I probably might use that a little loosely, but this one's, I think, is an interesting one. So why don't we actually just jump right in? So it's first worth noting that we know that cotangent of x is equal to cosine of x divided by sine of x. So why don't we actually utilize the half-angled property? So of course, utilizing that cotangent of x divided by 2 is of course cosine of x divided by 2 divided by sine of x divided by 2. Okay, so using the half-angle identities, we know that cotangent or cosine of x is equal to 2 times cosine square of x divided by 2, subtract 1, and then sine of x is equal to 2 times sine of x divided by 2 multiplied by cosine of x divided by 2. Okay, so we have those pieces. So sine and cosine, we can actually just plug those back into our cotangent definition. So let's actually do that. So then cotangent of x is simply just 2 times cosine square of x divided by 2, subtract 1. All this being divided by, so just substitute. So 2 times sine of x divided by 2, then times cosine of x divided by 2. Okay, so now the next thing is let's actually compute cosine or cotangent of x divided by 2, subtract cotangent of x. Okay, so by doing so, we have that cotangent of x divided by 2 is the same thing as, of course, cosine of x divided by 2, subtract or divided by sine of x divided by 2. Then we subtract this with just this equation over here that we actually just substitute. So 2 times cosine square of x divided by 2, subtract 1. All this being divided by 2 times sine of x divided by 2, and then cosine of x divided by 2. Okay, so now by doing so, let's actually now just get a common denominator for both of these. So let's actually just put this over here. So I'll put it equals. So by getting a common denominator out of this, we're gonna have 2 times cosine square of x divided by 2, then subtract 2 times cosine square of x divided by 2, and then add this with 1. So all this being divided by, so we can get a common denominator yet, of course. So this is just going to be, okay, denominator 2 sine of x divided by 2, and then cosine of x divided by 2. Okay, as you notice, these terms are just going to cancel, so we're just left with 1 divided by 2 times sine of x divided by 2 multiplied by cosine of x divided by 2. And so simply that just leaves us with just 1 divided by sine of x. Okay, so just like from earlier before, now here comes where we need to plug in our where we're going to start showing the equality. The left hand side is equal to the right hand side. So left hand side starting off, so I have 1 divided by sine of 2x, add this with 1 divided by sine of 4x, then all the way up to plus 1 divided by sine of 2 to the power n and then x. So then I would just plug in everything we did from the 1 over sine of x from this computation of cotangent x divided by 2 minus cotangent x. So then doing so, we have cotangent of x minus cotangent of 2x. Add this with now just cotangent of 2x. Add this with, or rather minus, so it's going to be subtract, minus cotangent of 4x, okay, dot, dot, dot. And then all the way up to the final term, we have cotangent of 2n minus 1x, and then subtract cotangent of 2 to the power n times x. Close that off. As you can see that we're gonna actually have some terms that cancel out. So we have this will cancel, thou cancel, so on and so forth. And with that cancel, we know that indeed that this is a telescoping series, meaning that only the first and the last terms are available while everything in between cancels each other out. So that means we're just left with just the last two terms. So therefore it's just cotangent of x and then subtract cotangent of 2 to the power n times x, which of course cancels out. That actually proves our equality of the left-hand side and the right-hand side, just like that. Just from utilizing, that completes the proof, as I should say. Utilizing, of course, the cotangent definition and its half-angle identity. As we can see, we just plug in some stuff. Utilize this equation to actually verify that this is indeed the same thing as writing as 1 divided by sine of x. Utilize its input for here, and then plug it back to here to actually expand the cotangent differences out and our sums rather. Add that together. Notice that we have a telescoping series, and then we're just left with these two terms just like that. Completing the proof, simple as that, just like that. Crazy, right? So yeah, that's pretty cool if you ask me.